Alright, welcome back to 23.3 Sampling Distributions. In Explain 1, we'll be going over using the sampling distribution of a sample mean. So, the histograms that you made in 2 Explorers, well, we could also see that in our textbook, are called sampling distributions. Now, let's go over a couple definitions of some stuff. Like the first one, a sampling distribution shows how a particular statistic varies across all samples of n individuals from a sample population. So remember, n individuals is how many people we are polling from our surveys, how many people we need to participate. All right, and that could range. Just as an example, it could range from 15 people or 15 items, 15 groups of data to 5 groups of data. It's really just up to you. So on the next one, the next word we're going to go over is standard error of the mean. So the mean of the sampling distribution of a sample means is denoted by, oh, there's that symbol again. So our sample mean. And the standard deviation of a sampling distribution is, oh, there's that symbol again, that cursive O, for that's our standard error of mean. Okay, so there's a couple of properties that we're going to go into and a couple things that we're going to kind of learn and use. It says if a random sample size of n is selected from a population with a mean and the symbol and standard deviation, then here you'll see this mean is equal to that mean. This mean can be found, or the standard deviation can be found by dividing our standard deviation divided by the square root of our sample size. So remember, n is the sample size of our group. All right. And then last but not least, number 3, just so you know, the third property is also known as the central limit theorem. So just FYI. But this is what it is. The sample distribution of a sample mean is normal if the population is normal. For all other populations, the sampling distribution of the mean approaches a normal distribution as n increases. Just so you know, like let's say I poll like 5 people in my survey. So I'm going to ask 5 people. Well, that's probably not going to be the best, most accurate sample size. So because just asking 5 people, they're going to have just a few different answers. It doesn't matter what I'm asking them, they're only going to have a few different answers. Now if I pull about 500 or 5,000, you'll see that it starts to, one, I have way more variety in my responses, but also my responses kind of start approaching a normal distribution, which we learned kind of looks like a bell curve. Normal distribution. Okay, so just keep that in mind as we start applying some of these in Explain 1. Alright, first example, it says boxes of Cruncho cereal have a mean mass of 323 grams. With the standard deviation of 20 grams. So that's just our background information. In part A, it says for a random sample of 36 boxes, what interval centered on the mean of the sampling distribution captures 95% of the sample means? Alright, let's first write the given information that they give us. Okay. So here again our mean, denoted by this symbol here, is about 323. And our standard deviation, denoted by this symbol, cursive O, is about 20 grams. Now our sample size, they say, if a random sample is about 36 boxes of cereal. So we've identified those values, and that's going to help us to kind of plug in some numbers here. So here, remember our find the mean of the sampling distribution of the sample mean and the standard error of mean. So here, we're just plugging this number in. So once you identify it, you kind of know it. The rest we're going to go ahead and calculate. So we'll put 20 on the numerator side, 36 on the denominator. Let's go ahead and work this out. That'll be 20. Square root of 36 is 6. And let's go ahead and divide that out. 20 divided by 6. And that's about 3.3. The next thing we're going to do is it says the sample distribution of the sample mean is approximately normal. In a normal distribution, just remember from the last section, I know this was a while ago, that 95% falls between two standard deviations from the mean. So that means that our standard deviation of 2 to the left and 2 to the right would be a total of 95%, just so you know. So that means we're going to take our mean of 323 and we're going to add 2 of our standard deviations, which was 3.3. We're going to calculate that out. For the left side, we're going to go ahead and do the same thing, only we're going to subtract 2 times 3.3. So let's go ahead and calculate each one of those out so we know what our range falls between. So go ahead and take some time and do that. And for this side, you should have gotten 316.4, whereas on this side, you should have gotten 329.6. Alright, so let's go ahead and go on to part B. So on part B, again, they're giving us kind of the same information. Our mean mass, otherwise denoted by that symbol, is 323, and our standard deviation, denoted by this symbol, is 20. What is the probability that a random sample of 25 boxes has a mean mass at most of 325 grams? Just so you know what at most means, that means that's the limit. That's as high as it could go. That means it could be lower. Lower is okay. But that's as high as it goes. That's like the maximum. So let's again identify some information. Our mean, as you can see, is going to be the same because it's the same type of problem. Our standard deviation is also going to be the same. However, our sample size is a little different. We're only going to pull about 25 boxes. Alright, so let's go ahead and again find the mean of the sampling distribution, which if you found that, you already know what it's going to be. And then the sample mean, which we did, and the standard error of mean. So let's go ahead and put in that 20 for that standard deviation. For our sample size, 25. Let's go ahead and work this out. So what's the square root of 25? 5, right? And let's go ahead and work that out. 20 divided by 4. And that's about that. Okay, so it says probability of a sample that is, again, at most, because that's what they said, at most 325, can be denoted as, which symbol would you think means at most? Remember, lower, it can be lower, it could be less, but it can't go any higher. Alright, that should be the less than or equal to symbol, just so you know. And there's 2 options. And we're actually going to use the normal probability calculator for sampling distribution. In fact, that's what I'm going to go ahead and Google in just a moment to show you one of the ones I use to find the probability. Just so you know, there's a lot of online great resources to help with calculating all of this stuff out. You don't have to kind of go out of your way to find them. In fact, all I did was I took a normal probability calculator for sampling distributions and I put it in my Google search engine and I clicked on the first result because why not? And as it loads its life, as you can see, we're going to go ahead and input all our information, which is our mean. So there's that. Our standard deviation, which was 20. And our sample size, which is 25. Now, it was important for us to kind of translate the at most into an inequality symbol, because as you can see here, they give us a couple of options. Do we want it two-tailed, like a range? Do we want it left-tailed, where it's only less than? Or right-tailed, where it's greater than? Since I got a less than symbol, I'm going to go ahead and click on left-tailed. I'm going to go ahead and type in 325, because it's all the values that are less than or equal to 325. And I'm going to press calculate. And as you can see, it's going to calculate for us. In fact, it says our solution. So it calculated that for us. And it says, therefore, the following is obtained graphically. So here's a visualization of what that means. So it's all the numbers up to 325 or less. And that probability is about 0.69, as you can see right here on our screen. So let's go ahead and write that in on here. And that was about 0.6915. That's our probability. As you can see here, it says stop and do the problems in your packet. So go ahead and do that right now.